welcome to the EvilTester show. My name is Alan Richardson and today we're going to talk about what is software testing. That's a big question and some of you will be here to get an easy answer for interviews, and that's fine. We're going to cover that, but we're also going to cover why it's more important to construct your own definition and your own models of what is software testing. So if you want to find old episodes of the show, you can go to eviltester.com/show. There's RSS feeds there, various links for downloading this as both audio and video. So, what is software testing? This is a question that I have been looking at for at least, I don't even know how long. I have a certificate here from 2002 where Alan Richardson has successfully completed the exploratory testing workshop course. This was taught by James Back, so this is 17 years ago. And during that workshop, James asked the question, what is software testing? And encouraged us to come up with our own definitions. Now, up until that point, I had created models of software testing because I was reticent about trying to create an actual definition. But I started to work on definitions and I've been creating definitions of software testing ever since. I'm just refining the same definition. So, since people want easy answers, one of the interesting things is, why do people want easy answers? Why do people ask this question? Very often this is an interview question, what is software testing? And the interview is wanting, what is software testing to you? So that I can evaluate it. But very often what you'll get back is, what is software testing in terms of the ISTQB definition? What is software testing in terms of someone else? And that can be a useful strategy because you're trying to sell yourself into someone who has preconceived notions. So ISTQB, and you can find the definition on their website, because the syllabus is freely available, says software testing is a way to assess the quality of the software and to reduce the risk of software failure in operation. And then there's a bunch of objectives and various other things. So, fundamentally, this looks like we're trying to assess the quality of software, and by doing that, we somehow reduce the risk of software failure in operation. Great. So that's software testing according to ISTQB. I might look for the pithy definition in the glossary, but the glossary at the moment is broken, so I can't do that because software testing is an important thing to do so that we don't have defects in live. It's one of the reasons why we test software, but that is almost independent. That's a side effect of the actual definition. Wikipedia, if you look it up online, says that software testing is an investigation conducted to provide stakeholders with information about the quality of the software or service under test. So a lot of times when people talk about software testing, they're talking in terms of information provision. Quality comes up a lot, verification, validation. So these are important terms that if you're speaking to someone who wants you to parrot someone else's definition, you should put into the conversation, because the aim of an interview is to try and get the job. So use other people's definitions. But the notion of definitions and modeling software testing is fundamental to your understanding of software testing, so it has to at some point become unique to you. Now, if you're speaking to someone who is less associated with the ISTQB world, you might want to find a definition from James Back or Ken Kamer or someone else out there that's associated with context-driven testing. So here I've picked Ken Kamer's definition from presentation that he's got, which is also listed on Wikipedia. So if people are doing lazy web, they'll look up software testing on Wikipedia, and that will be the set of definitions that they will be expecting you to come back with. So Ken Kamer has written, software testing is an empirical technical investigation conducted to provide stakeholders with information about the quality of the product or service under test. There you go. So again, it's an investigation. It's for providing information about quality to some person. So there are common themes in those definitions. But what we have to do is learn how to go meta. So if you're here for interview type questions, that's pretty much it, right? That's the interview definitions. I'm expecting to see drop off on the videos or podcast listening at this point. But what we're going to do now is go deeper into that, to go meta to those questions, why we ask those questions, how we can explore it for ourselves. So if we were asked the question, what is software testing? Sometimes it's not the answer that's important. It's who is actually asking this question. What background do they have? What terms do they understand? Because if we want to communicate what we believe software testing is, we're going to have to communicate it in a way that they can understand and in their terms, not our terms as a software testing industry, but in their terms as whatever they are coming from. And also, we have to consider, did they actually ask the right question? Right? Because what is it that they want to know? Perhaps they want to know what you do rather than what software testing is, because those can be different things. And what are they going to do with the answer? That's important to how you answer that question. If they're going to then pass that answer off to someone else in a completely different sphere of understanding, different set of technical knowledge, you need to give them a different answer. If they are going to choose whether to employ you or not, you want to give them a different answer, an answer that they like and relate to. Because questions are for the person who has asked it, not necessarily us. Except when we ask that question for ourselves. So asking the question, what is software testing, so that we can answer it is incredibly important and useful and frustrating and challenging and will keep you busy for years. So when it's a question for someone else, we have to bear in mind that at this point it's really a sales pitch, right? You're trying to help them understand something, presumably because you want them to see software testing as important. You want them to employ you. You want them to give you more staff so that you can do better software testing. You want them to give you tools so that you can do it better. So there's something out of this. There's a business relationship going on. So if we look at it in terms of sales pitches, then we're looking at it in terms of, well, what are their needs from software testing? And try and have the definition address that. What do they value from the process of software testing? If we don't know that, we might not be able to pitch this in such a way. And if we don't know that, we might not be conducting software testing in a way that meets those needs and values. And then we've got what they want, what they hope to achieve from this, what they'd ultimately desire for this, so we can tempt them in to really looking for good software testing. And then we've got the avoidance pitches. So what are the risks that software testing helps you mitigate or address? What is the fear that we want people to move away from and embrace more or good or better software testing? And some of these definitions cover that. Ken Kamer is looking at information, so they can help reduce the risk, so they understand the quality, so they can know that they're going live with something that the customers will want. The Wikipedia one is, again, quality investigation. ISTQB is to reduce the risk of software failure, right? We're addressing a risk. If we don't do this, there's a fear response, there's a risk in there. These are a result of taking a sales pitch type approach to the definition, which is important. Now, one of the reasons that I avoided definitions for the longest time is that I viewed definitions as prescriptive. So having a definition would then cause me to work in a specific way. And when I do that, the definition has to be all-encompassing. Right, any definition of software testing will grow and expand because it has to cover everything that I do. So I was nervous about definitions. But then I learned to treat definitions as descriptive, to approach them as models at specific times for specific communication purposes, to help me learn more about what we're doing, and to allow for multiple descriptions, so that I don't have to have a single description of software testing, single definition. I can vary it based on who I'm talking to, what situation that I'm working in. That can help me think about it differently. And it's a hard question ultimately because we learn more about software testing over time. Our views about software testing change. And because our views about software testing change, we should expect our definition and our descriptions and our models of software testing to change with that. Part of the issue we also have is that people identify with a role. So people identify with a being a tester. The tester does testing. So if we say what is testing, it really has to cover everything that tester does, because they're so invested in that. Roles become part of their identity. I am a tester. Testing is what I do. This is what I do. My definition must cover that. So a strategy for helping with that is to identify with multiple roles, because inevitably on any project you are going to have to adapt to the situation at hand. So some of what you do will be completely related to software testing. Some of it could overlap with business analysis. Some of it could be doing some programming. Some of it could be managing timescales or budgets. Your definition of software testing doesn't have to cover that, because you can embrace multiple roles. You can have attributes from different roles. Try and go, so acknowledge that you have multiple roles on projects, and the definition does not have to encompass all of that. Or you can go meta. Right, so I identify more with software developer than software tester, simply because I have to do analysis, management, consulting, schedules, budgets, programming, architecture, ops, releasing things, creating environments, the entire process of software development. So if I identify meta and acknowledge that at times I will be purely testing, I will be focused on testing, and at that point I will be doing the testing role, and that will be where my mindset is. But then I have to switch out and view it analytically from a management role. Have we done enough of this? Are we testing the right things? And switch back and forward between it. So having a meta role helps me, but also the acknowledgement that I adopt different roles at different times in the project. Those things can help. But if you're vested within a particular role, coming up with a definition can be hard, because you want it to encompass everything you do. So having looked at other people's definitions, my working meta model for software testing is, in fact, for any testing, is comparing models of the thing with the thing. Right, that's nice and simple, but I think that encompasses a lot of what I end up doing. And there's an important focus in there for me, which is the notion of models and modeling, because that is absolutely essential in the software testing that I do. I construct a lot of models. I'm aware that when I'm working with the system, I may not know, in fact, I don't know exactly all the bytes that are in that software system and where they are in memory. So I'm working with a model of it, a perception of that system. So models are key. And I'm also aware that I'm comparing things when I'm looking at a system, when I'm evaluating it, when I'm investigating it, in order for me to identify whether there's a problem or whether it's working as I expect. I have to have a model in my head, and I'm comparing it with what I'm observing. So at a high meta level, I compare models of things with things. Then, to become more specific, when I'm looking at software, I'm comparing models of a system with the observed interactions of the system. Now again, I'm choosing words that are useful for me to remind me of things. So observed interactions is telling me that I'm only at a surface level. Whatever I'm looking at, I'm only at a surface level. I haven't seen all the memory changes that have been made when I'm working with the system. I'm observing the GUI and seeing things change in there. So there may be a mismatch between the GUI and the back end. Perhaps we're working on an event-based system where the GUI is telling me that something's happened, but in the back end, that event is still in a queue and it is still being processed, and it might still fail because I've got observed interactions. So fundamentally, even when I'm working with the system, I'm working with a model of the system which is based on the observed interactions. And again, I'm comparing models. But then I have to go a little bit further, because why am I doing this? I want my definition to hint at what are the reasons for doing this, because otherwise I'll just keep building models and comparing models and building models and comparing models. But what's the purpose of that? And this has been hinted at in some of the other definitions. They've gone further than this comparison definition. So I do this comparison for the purpose of evaluating the comparison and refining the model. So what does that mean? Evaluating the comparison. Well, very often we talk about information. Where does that information come from? That information comes from evaluating the difference between the model that I have in my head that I'm using to test and the model that I've made of the system in operation. So I then have to decide, do I tell someone about this? Is this important? Is this something that is simply coverage because it confirms what I thought I knew, or is it difference, in which case it's information that I might want to tell something that perhaps there's a problem here? And I also use the information to refine my model, because my models are not stable just because I have it in a model. And sometimes if our model is a requirements model, comes in and says, we must be able to do X, there can be ambiguity in there. So when I work with this system and I compare it to my requirement, the ambiguity, I might refine that based on what I'm observing the model. I might go and ask a question. The model that I'm working with, the requirements are a little bit ambiguous. When I see this in the system, is that what this means, or should it be doing something else? And I'm building and changing the model. And the degree to which I do that is really hinting at how exploratory and agile our process is. Because in a waterfall and tight, highly structured project, you might not expect very many refinements to your model, because your model is supposed to be absolute, and the refinements would be in the system that you're observing, because any deviation from requirements which have been spent months on and are completely unambiguous and completely correct, that the system is clearly incorrect at that point. But when you're working in a more agile way and you're exploring and you're building things up to see what it does and to see if it meets people's needs, and then there's more flex, and then we'll be building up the model. But it's a model and we expect models to change. Now, those definitions that I just described are not the same as I was working with a couple of weeks ago. A couple of weeks ago, I had software testing as a process where we compare a model of the software to the software or another model of the software for the purposes of refining the model and identifying changes that could be made to the software. That's subtly different, but I was possibly doing different work at that time. I was possibly thinking about this in a different way. So our model changes over time, but every time we codify it, we have something that we can use to guide us to think more deeply about the way that we interact with software and our environment. Now, one of the things that's interesting to me is, should I really care about what software testing is, or should I care more about what I do when I do software testing? Now, they are clearly related. Sometimes the roles that we inhabit, if it's outside what we view as testing and it's a programming role or an automating role in support of testing, the how might not actually fit into our definition. That's okay. But we do have to evaluate both. And very often I stayed away from definitions for the longest time because I didn't really want to know what it is as an absolute, because I wanted the ability to flex, and I care much more about how I work. But how I work is much more contextual than my definition. So I care about both. It's not that one is more important, but very often we put what is software testing much, much higher than how do we software test? How do we test software in this environment? What skills do I need? And these other questions are of absolute interest, and they can sometimes fall out of the definition, but I care about what software testing is because I want to refine my models that guide me to help me look at what is actually key and essential and important about software testing, so that when I look at multiple projects and multiple ways of working from different teams, I've got my essence, and I can look at how well are they doing this essence, how are they implementing this essence, what are the risks in terms of what have they missed out of that essence in there, because very often modeling is missed out. Very often the notion of refining and expanding your models is not present because we don't, people want to automate a lot. The information that comes back from automating is really confirming the model or confirming the system doesn't match the model, but not really expanding the model. So we've lost that expansion part in some teams. So having a meta model that has that essence in there helps me as a consultant when I'm evaluating teams, and helps me look at my process, because having the notion of observing the interactions in the system is absolutely vital for me, because I'm looking for new ways of observing the system. What interactions have I not observed? And I'm conscious that the accuracy of my model of the system is only as accurate as the observations that I'm making and the tools that I'm using to make it, and that there's risks in the sections of the software that I'm not observing, that I'm taking for granted. So that model helps me. Now, when I look at this, I have to start understanding, well, where does a model come from, right? And it comes from multiple places. So it's not a single thing, which is why I say the word models. So I've got my models derived from requirements. I got my models derived from stated needs, wants, documentation. Comparisons from other systems might be important. What does our competitor do? That might be a model that I bring in and use to help me explore the system and compare that model with our system to see whether they have a competitive advantage, whether there's an industry standard that really we should be doing. And exploration is key to this, because it's how we expand our models. How do I come up with new ways to compare? Because that comparison isn't set in stone. So that comparison is an exploration process, an experimentation process, an investigation process, a discovery process. We may automate that in order to do obvious comparisons that we want to just keep making sure that they confirm, right? There's a lot of nuances hidden in those words because it's a high level meta model, and refining the model means expanding it, making it bigger, because we learn more about the system. There's more things coming. Maybe I should partition this model in different ways. Maybe I should have more and different models from different angles. What aspects of the system have I not modeled or considered yet? And sometimes the model will be incorrect. So I will need to amend the model based on what I have learned, either through observed interactions or questions when I have evaluated that comparison and asked someone else, should it do this? And then I discovered that my model needs to change, that I was using to drive my process. Now, this might lead to changes to the software. And this previous model that I had that said identifying changes that could be made to the software, that wording was there to make me realize that it's not an absolute. Just because the model differs from the software, it's not an absolute guarantee that that change should be made. Perhaps we have the idealized model, and perhaps we have an acceptable model that we will live with now, and that in the backlog there's an action to bridge that gap and make our acceptable model closer to our ideal model. So we have to have models and definitions that support the flexibility that we need to bring into work. Now, I talk about comparing models rather than confirming models. When we automate, we're confirming models. We've codified conditions that we want to continually evaluate and assert on, so that's a confirmation process. That's almost a side effect, and it's less interesting than expanding and refining the model, because that's where we get new information. Very often we're talking about information that we want to give people. If you keep coming back and your information is, I can confirm everything is exactly the same, no one's going to find that interesting. Information should be interesting. It should be something that is challenging or changing. So we're looking for expanding either the reach of our observation so that we can more accurately compare on a different level, or change our models to compare at different levels, or change our models to widen them, to look at them from different angles, to have different data coming through. It depends what models you're using, but you can step back and actually look at the really state of your models and go, am I actually comparing enough things? Am I driving this with enough different models to help evaluate and provide useful information to people? And again, that comes back to that sales process type questioning. What are the needs, wants, desires of people? What are their fears and risks? That's what our information should be targeting. And when we talk about bugs, defects, errors, failures, they are noticing comparisons. Difference in our comparison. When our comparison said our model didn't match the system, that might be because there's a bug. That might be because there's a defect. It might be because there's an ambiguity. It might be because our model's wrong, right? That comparison failure is where we get new things, and we have to be able to notice that, adapt it, change it, and observe at different levels. Now, if I was to give you a diagram, it would have the notion of a model, probably as a set diagram. So model is one set, and it would overlap another set called software. So sometimes the model is going to match exactly. There's going to be things in the software that I haven't modeled, need to expand my model. There's going to be things in my model that are not in the software. We thought they were. They might not be important. So we've got an overlapping type diagram. But when I have the notion of software, and very often we're talking about software testing, that software, that word software, is really a shortcut, a name for the observed behavior of the software, because I'm not really working with the software. Software is in memory, it's bytes, there's executable code. I really don't know what that is. I'm observing the behavior of the software. So the limits in my testing and my ability to evaluate are limited by the observations I can make, the tools that I'm using, the accuracy of them, the speed that I can get, the amount of things I can observe in parallel at the same time, because I can't observe everything. And fundamentally, it's a model. So really, I'm comparing models with models. That, I think, is an important distinction, because then we might be aware that we're actually modeling the software itself wrong. We might have a fundamental misunderstanding of what this does or how users put it to use. And we might, because if we think about software, we might not be aware that we really are not observing very much of that software at all. Now, I was slightly reticent to put this this podcast together, because when we share our models, when we share our definitions, particularly, people don't look at them as models, and people have their own definitions. So when they look at your definition, when I give you my definition, comparing models with other models, you contrast that with your existing ones. And it's very often not done in order to help you expand your model or change your model. It's to defend your model, right? So if I look at definitions, it's very easy for me to go, aha, like Ken Gamer said, this is about information about the quality. Well, no, it's not about the quality of the product or service. It's about whether there's any issues in there that have not been spotted, and the users don't care about the quality of this, and we've got tech debt. And really, it's about how much tech debt have we put in there, and what is the risk of this for the future. And I could take issues with definitions if I want to, but I have to understand that definition, Ken Kamer's definition, is a model. Mine is a model. I don't need to defend my model and my belief when faced with someone else's. I can look at what is important in there. It's important to note that empiricism, empirical investigation, is a useful nuance. And to me, think, have I got that nuance in my particular approach? Does my definition imply that? How can I have that nuance inside my model to then expand it? Because models are very often a representation of our beliefs, and we defend our beliefs because very often we're not used to having multiple models and accepting multiple definitions of models, or even accepting that these models were created, these definitions were created for different audiences, and we're not that audience. We might have learned more than that audience was pitched at. So do look at these things, but I get nervous because I know that people are going to listen to this and go, that's not the correct definition. And that's fine. That's my working definition that is helping me at this point in time, because I am continuing to learn what I'm doing. And I think fundamentally that is the most important thing, right? It's absolutely useful to build your own definitions for your use, for you to think about, that communicate to you. And I'm going to encourage you to go meta in your definitions. So you don't just model your role and what you do and try to have a definition that encompasses that. Try and get to the essence of what you're working on. And because you're going to have multiple definitions, you don't just have to have a definition. You can have a definition, a meta definition, but you can also have a definition of what software testing means in the environment and context that you are working with. You can have it for the specific task that you are working on to keep you on track. What does testing this particular feature at this point in time for the next 10 minutes actually mean? Having the ability to construct different definitions at different times for different purposes will change your approach to testing, right? Because fundamentally, having the one true definition is much less important than the actual process of continuing to revise and expand your definition. Having the ability to support your communication with other people and vary it, because it's much more important that the definitions and models we have aid our thinking and growth, because the construction of definitions is one of the absolute instantiations of a testing process, where we have a model of testing and we are comparing it with what we do in reality, and does our model match that, and where are the differences, and what do I have to do differently? Do I need to change the system that I'm testing? Do I need to change how we're testing it? Embracing all of this in a single headspace is massively important. So I've been doing this for at least 17 years, just in terms of definitions. But prior to that, I was doing it in terms of models, and I still do it in terms of models. I create models of this. So it's not a process that is going to end. You're not going to have one definition that's going to serve you forever. So don't worry about it being perfect. Just make sure it's useful and adds value to you. And if you find this podcast useful, adding value to you, make sure you subscribe either to the blogs or on YouTube, but head off to eviltester.com/show, where you can find all the links and you can explore my blog and other information that's out there. But thanks for tuning in.